Hello, everybody. Let's start our today's class. OK，OK，
Yes, 老师。
大家好，我们上课吧。呃，
嗯
首先，我想讲一下我们的作业。So, actually, I have received maybe 6 or 5. You guys have finished your homework. But you guys can look at this page. I think almost all your homework is the same with this one. Actually, this is homework from BE grade 2020, although the result is correct, but you guys can find, I reply to you guys if you have submitted your homework to me, I always write as 方法不对, Actually, I hope you guys should use what we have learned, the theorem of velocity and acceleration composition. But I think I should say, actually, this method is very clever, So all of us can look at this method first. Then I will show you guys how use our method to find the same answer. So let me read the problem. You can see from O1A and O2B have the same length with 10 centimeters, right? And O1, O2 equal AB. So actually we can give this conclusion O1, O2, BA is a parallelogram. So the geometry is such that the link AB is always horizontal. So actually this is a very clever conclusion. So because this conclusion, this girl have this method. I don't think all you guys totally know this method. So I think it's not probably most of you are copy this girl's homework, right? I think that is. So her conclusion is, so if we draw a perpendicular line to this O1, O2, we know that in this body system, O1, O2 are two fixed points. So O1, O2 will always keep at this position. So actually, this point A will have a circular moment because of the rotation of this O1A, right? So if we give a reference perpendicular line from point A to here, we got a point E. So we have the length of AE will always equal O1A times sine phi, right? So we have AE equal 0.1 meters. So we can change this unit from centimeter to meter times sine phi, right? So maybe this problem is difficult for you guys. So you guys only can copy his answer, but you guys cannot finish by yourself, right? So since we have this, we have this because we have O1A and O2B rotate at a constant equal to radian per second around O1 and O2, right? So actually we have its rotation function will be phi equal omega t. Actually we can write as, I'm sorry, should 2 times t, right? So here we have AE always equal 0.1 times sine phi. So we can do these two derivative calculations. So one is dAE dt, right? Equal 0.1, because this sine phi is derivative with cosine phi. But here not phi, should be phi dot, so we can find phi dot actually equal omega equal to rate per second, right? So you can find here should be phi dot. So here is omega, then we can find VC, right? So because this AE will always perpendicular to this O1, O2, so we can just use this to find the AE squared dt squared. Then we should do this because here we have 0, 1 times 2 omega times cosine. You can write as omega t. So we have 0, 2 cosine omega t. So when you do the second derivative calculation, we should from this expression. So here it should equal what? Equal 0 point minus sine omega t times omega, right? So we have minus 0.2 plus times 2 times sine omega t, right? And it tells us actually here phi equals 60 degree. So we have actually 0.4 times sine 60 will be, I think, square root 3 over 2. So the final result will be 0.2 and the square root 3. So it units will be meter per second squared. So I have validated this answer. This two answer is correct. Actually here we can use 0.2 times cosine 60 equal half, right? So here will be 0.1 meter per second. So all these two results is correct, but I think it's not the method we should use. So almost all your homework I give this mark, I think it's half correct. And this half, I think all you guys are copy this girl's answer, not your self answer. So back to this page, I want to show you the correct method we should use. So actually from that girl's answer, we know this O1, O2, AB is a parallelogram. So that means we have very important, conclusion is this O1, O2, AB, because of this O1A equal O1B and this O1A parallel to this guy, also O1, O2 parallel to this guy. So this link AB, this link AB will have translational movement. Translational movement. Do you guys still remember, actually, we have learned two simple movement of a raised body. So link AB actually is a typical raised body. It can be translational movement. It can be rotation around some fixed axis. It also can be very complicated movement that is plane motion. So today we are going to continue to learn this plane motion, But because of these conditions, we know actually AB will always have translational movement. So that means we can use these two composition theorem. Do you guys still remember? We have absolute velocity equal VE plus VR. So we also have another acceleration is AA equals AE plus AR, right? So actually, I hope you guys use this. You guys use these two theorem of velocity composition and acceleration composition to find the final result. It let us determine the velocity and acceleration of bar CD. So I think the principle of this body system is difficult for you guys to fully understand. So actually tell us this axis O1 and O2, So actually, because this is the parallelogram, so actually O1A and O2B always have the same velocity and acceleration. Because there are two raised body have rotation around fixed point O1 and O2 respectively. So actually, here we know from here, O1A have a uniform, constant angular velocity. So the first thing we know is actually VA should along this direction. So can you guys understand what I'm talking about? So actually here should be perpendicular. It have get this CD, this bar CD, it only can move along the vertical line, which is CD, right? So because the get it of this fixed slot, this CD, it can only move up and down through this hole. It only can move up and down. So actually CD is another raised body with translational movement. So after all this analysis, I will change another color for you guys. So in order to use this theorem of composition, velocity composition and acceleration composition, so we should give this, what is our moving point? So because this is a very typical example, you guys should remember that we always select a point on the sleeve C. So our moving point will be C. And our moving coordinate system will be link AB. So you guys should remember we should use this selection because when we are imagining that we are sitting on AB, we look at this sleeve C, it will have a relative movement along AB, maybe along this direction, maybe along this direction. And our SCS is always Earth ground, right? So that is what we have learned from chapter 8, right? So Earth ground. And since we know actually because of the guidance of this fixed slot, this CD only can movement upward and downward. So this point C, our moving point, also a point on CD. So its absolute velocity will along this direction. It's hard to draw a beautiful picture, but actually here should be VA. And what is VE? We call that transport velocity. So I always tell you guys, actually, we should think about that at this moment, there is the C prime, which has same position with moving point C, but actually this C prime is a point on link AB. Why? Because link AB is our moving coordinate system. So since AB is the rigid body, have a translational movement. Do you guys still remember a translational movement rigid body? Any other 2 points will always have the same velocity and the same acceleration, right? The same acceleration. So here our VC prime, actually, it will have the same magnitude and same direction of VA. And we know VA is direction and its magnitude. So actually, because this is 60, is 60. So here is 120 degree. Because here is the perpendicular, so we only have here will be 30 degree. Then we can use this orientation. We can draw like this, this is VE. Actually, our VE will have a 30 degree from the horizontal line AB, and its magnitude will equal VA equal 0.2 meter per second, right? So the last thing for us is draw what? Draw VR. So we have VA here, we have VA here, we have VE here. So VR, when we are thinking about, imagine that we are sitting on MCS, that is AB, we look at this point C. So it will have relative movement along AB, maybe along this direction, maybe along this direction. How should we choose one of the direction? So actually it should along this direction, it should along this direction. So here is our VR. You know why we should select this direction? Because this is the vector equation. I think I have told you, we always should to make sure that this VA will at the position of the diagonal line of this parallelogram, because the three vectors VE, VR, and VA, actually this VE plus VR will use this parallelogram. It will constitute a parallelogram, and this VA always should on that diagonal position, right? So if we draw VR like this, you can find actually we cannot make sure that VA in that parallelogram diagonal position. So VR should be this. After we finish this, it's very easy to find VA, right? So we have different methods. So I can show you guys. The first one is we should use the projection method. Actually, we have talked about this projection method through many examples. So in order to eliminate this VR, because we do not need to calculate the magnitude of VR, because it not ask us to do that. So we can select a direction like this. So we assume that this is positive direction. So we can write like this. Project, project our vector 1 onto CONC1. This CONC1 is the name of this axis. Then when we do this projection, we shoot from left to right. So, VA actually, it is on the axis. So we just write its magnitude like VA. We just draw its equal sign here from here. So we can find actually VE, if it has an intersect angle with horizontal line, then here this angle will be 60. So we have VE, times cosine 60. And because VR it is perpendicular to this vertical line CONC1, so its projection onto this axis will be 0. Then, we can find because VE equal VA equal 0.2 and cosine 60 equal a half, right? 0.meter per second. That's how we use this theorem of velocity composition to find the velocity of bar CD. So until here, can you guys understand what I have talked today? Can you guys understand this? I cannot hear your guys' voice. Are you guys still listening to me? Okay, since no one replied to me, I have to just finish the second step, how to find this acceleration of RCD. No? Does anyone still follow me? Hi. Very sad about that. So we should use the similar pattern of how to use this composition of acceleration, right? So because here a little bit mess, so we should not draw picture here. So the second how to find it, we know actually this O1A rotate at a constant angular velocity. So if you guys to remember actually this AA because it's omega is constant. So it's AA will only have a normal component which will equal omega squared times LO1A. So that is 4 times 0.1, so will be 0.4 second square. So we can draw like this because actually AA will along this direction. You know, so this is AA. So from this equation, so we can select here. So you know, I always use this method. So actually this is CD. Because the guidance of this fixed slot, it absolute acceleration also will along this direction. So this is AA. Maybe I should change another color. I should change another color. So since we know actually this direction of AA have 60 degree, then we should draw a 80 line like this. Maybe I draw like this. So this AA actually is our transport, our transport acceleration. Because this link AB is our moving coordinate system. And then we want to make sure that AA in the diagonal position of this parallelogram of this two sum of two vectors AE and AR. So we will draw like this, VR. This AA, this AE, and this AR, and our AE actually equal this. So we know here is 60, and then there will be 30 degree. So once again, if we see that this is equation 2, so equation 2 project onto the same axis, C1. So we have actually AA equal, AA equal AE is this AE cosine 30. And AR, because it is perpendicular to this axis C1. So we just find that AE equals 0.4 times cosine 30 equal square root 3 over 2. So the same result, 0, this. So we can find the same result to here, 0.3464. So maybe you guys will find why we don't have a minor sign, why we don't have this, you know? What? I'm sorry. So, I said that these two results also correct, because here is the derivative calculation is have the default assume that it should along this direction, downward direction, and from the method we have used, so we assume the direction of VA and the direction of AA actually is upward. So since our result is positive here, I think, positive here and positive here. So that means the real direction of velocity and acceleration of bar CD will be upward. Because that girl is use this method, actually just use the derivative calculation to AE, so it will have this manner direction, this manner sign, right? Just because this. So I have finished this homework. I hope you guys can try to understand that. I hope you guys should use this. But I think today maybe this content is very difficult for you guys. Maybe there are no guys are listening to me. So can you guys someone replies to me now, so I can continue my lecture? If I just decide to myself, why should I do this? Is there anyone still listen to me? You just show your name on the list. There are no anybody replies to me. Okay, I hear someone's voice. It's very little.
Yes, Laushi. Yes, we can listen.
Okay. Thank you for your reply. Can you understand what I have finished this homework?
Yes,
Can
Laushi.
you understand that?
Yes, Laushi.
You can.
Yes.
Okay. Okay. So since I'm very happy that at least you are listening to me, so I will continue our lecture today, right? So
Yes.
that's the homework of last time. Today we are going to continue to learn. I think we have finished the introduction section of chapter 9. Actually, we gave definition of plane motion and last time maybe we just stop at here. Here we have finished. Actually, we can use these equations of plane motion to denote raised body. Just a plane figure is plane motion. We just need 3 equations, right? And today we're going to tell you guys how to use it more like the composition of velocity from the last chapter. So actually, I think I have to tell you guys. So because this plane motion is very complicated, actually it has translational component. It also have rotation component. Actually, these 2 components happen simultaneously, right? But we can simple that complicated motion into just 2 simple independent one. So that is superposition principle. So actually, if we select the pole A, so we can find actually is plane motion can be divided into just 2 components. One is translation with the pole A. So this pole A you can think about is more like a reference point. In many cases, we know it's velocity and acceleration. So actually, the plane motion of this figure, it can be divided into 2 components. One is translation with the pole A, which means this component, it have the same velocity and same acceleration of pole A. And the second is rotation above the pole A. So this component, we can think about that is more like that this pole A do not move anymore, and then this figure will have a rotation above the pole A, right? So if you can totally understand this principle, then it will have very helpful to understand this the sequence content we are going to learn. So plane figure S moves from position 1 to position 2 in the interval delta t. So if we select point A as the pole, you can think about that actually this pole is the reference point. So translate the figure together with A to the position A prime B prime. You know, actually, so here it tells us actually the final position of AB at position 1 is vertical, and at position 2, actually its final position is this A prime B prime. But in order to simplify its analysis precise, we can think about so if we select this point A as a pole, actually the reference point, it can be think about that translate the figure together with A to the position A prime B double prime. You see, we just let this AB first have to translate with point A, keep its original orientation, right? Because its original orientation is vertical position, so you can find A prime and B double prime also keep its original orientation, but its position is changed from A to A prime. So this is A prime and B double prime. And then rotate it around A through an angle delta phi 1. No, can let this A prime B double prime change to its final position A prime B prime. So this is the first we select point A as the reference point. We call that a pole. So you guys can find actually we can select any point to be a pole or to be a reference point. So the second time we select point B as the pole. Then translate it. It means AB, right? Translate it together with B to the position A double prime B prime. You see? So this time we use B as the pole, as the reference point. So first we let this AB translate with B from B to B prime and keep its original orange. So we have this intermediate position of B prime A double prime. So you can see actually this will keep its original orientation. Then you can rotate B through an angle delta phi 2, right? Delta phi 2 to the final position A prime B prime. So you guys can find actually from these two methods, the one is select A as a point, a reference point. The second is select point B as a reference point. And you can find, since this A prime B double prime have the same orientation to AB, and this B prime A double prime also has the same orientation with original AB. So it's obvious that this A prime B double prime parallel to this A double prime, right? So that means delta phi 1 will equal delta phi second. That means this rotation component is independent to the pole you are selected, right? That means we select A, we select B, or we select any other point as the pole. It will have no any influence to the angle this figure will rotate around the pole, right? So that means delta phi 1 will always equal delta phi 2. Then if we do the derivative calculation, then we will have omega 1 equal omega second, right? So that's the principle. That means we have this, right? We have this conclusion. Omega 1 equal omega second and alpha 1 equal alpha second. So that's why we have this conclusion. And so let's do a short summary. So it is conclude translation in plane motion depends on the selection of the pole. However, the rotation about the selected pole does not depend on the choice of a pole. In other words, the instant alpha means angular acceleration, omega means angular velocity of any rotations about any poles are the same. So the selection of pole is arbitrary. It's arbitrary. We usually select the point with no motion at the pole. So I think I should better to do the explanation. What is the pole? So I think I have told you guys the last time pole it's more like a bar. In China, we call that 杆子, right? It's like a bar. So actually here in Chinese, our Chinese textbook call this pole as 基点. So I think it's more like a basic point or reference point, reference point. So if I just draw a figure which have a plane motion, if we say that this plane figure have a plane motion, that means any time moment it will have two components. One is translation, right? Another is rotation. So since this plane motion is very complicated, if we try to analyze its motion, so we should select some useful method to simplify this into two simple parts, right? So you guys can think, I have a bar, I have a bar. Let me show you guys. Then I use this bar. I hope you guys can understand. I'm trying to explain to you guys. I use this bar to poke this figure, and then maybe here we'll have a hole. Because I use this bar, poke this plane figure, so there is a hole. And then you can think about that. This bar is in this hole. This bar is in this hole, right? This bar is through this hole. So when this plane, because since this figure is a plane motion, it have two components. One is translation component, the other one is a rotational component. So you guys can think about. So since we can think about that, this complicated motion, although these two components it happened simultaneously, but we can think about actually it happened successively. We can think about translational movement happened first, then rotational component happened second, or rotational component happened first and translational component happened second. Right? So you guys can think about that. So we can imagine the transport, translation is happening. That means this figure will move its position, but keep its orientation. So we can just select AB, select AB as a reference, because when it happening this translational component, this AB is orientation will always keep its original. Then you can find this bar have to move with this figure, right? So when this translational component finished, then the rotational will happen. So if we select this hole in the pole, that means when the rotation happening, then maybe it will have a rotational around this hole, but this bar will do not need to move, because the whole other part of the figure can rotate around this hole, right? Can rotate around the hole. So that we see that if we select some point M as the pole, that means any other point on this figure is absolute velocity and acceleration can be divided into two parts. So one is translate with this pole, another is rotation around this pole. That's why our conclusion here. This is very important because we will use this principle to give some important conclusion, and then we can use this conclusion to tackle some problems, right? So please, you guys keep listening to me. So the first one we'll talk about the velocity of a point in a plane figure. So you see, that is the composition method is more like what we have learned. You know, we have learned absolute velocity equal transport velocity plus relative velocity VR. But here we are talking about just one plane figure. You know, we know that this plane figure have a complicated plane motion. So if we select A as a pole, we can imagine that we fixed a moving, we fixed a moving MCS to point A. So when this point A is moved, our MCS will move with this A. But when other part are rotation around the point A, and then our MCS will do not move, right? So that means we fix the MCS to point A, so the moving motion is translation. So here, consider the moving point B. It's just any other point on this plane figure. So its motion can be viewed or divided, can be viewed as composition of translation. So it's more like the transport motion VE, right? And rotation is more like relative motion. That is, we can use that this velocity VB, you know, its absolute velocity VB can be viewed as two components. One is its translate velocity just with the pole, that is A. Another is the relative rotation, that is VBA. No? So that means actually here VA is VB. The transport motion, transport velocity actually is VA because our MCS are fixed on point A. So actually this VE is the point on the MCS. So actually this is the velocity of VA. You know, this is very, very important because this VBA, it means the rotation component of this plane figure. So it will always equal this omega times the length of AB. You know, so if we use this figure, so assume that we know the absolute, the magnitude and direction of pole point A, we know VA. So this VB will equal VA plus VBA, and VBA will perpendicular to length to line AB, right? So you should know that we should always keep this VB will on the diagonal position through at this parallelogram, right? This parallelogram. And so VB will always equal omega times length, length AB, right? And because we know its direction is CCW. So if its direction is this, so how can we make sure that VBA will along this direction? So you guys can think about V per long AB a little bit, right? Maybe added line here, then we should rotate this added line around B along the direction of omega. Then we just rotate 19 degree. Then you guys can find actually we get this VBA, which it should perpendicular to this one. So it is time for us to have a short break. Our class will restart at 11:10, right? So you guys have a short break, please.
Okay, 老师。
好的 thank you. Okay, you guys, our time is up. Let's continue. Actually, I think here is a very useful conclusion. If you guys cannot totally understand why it is, so I recommend that you guys can think about the other way. Since we talk a lot of the principle of plane figure is plane motion, because we have talked about that it has dependent component. One is translation, another is rotation, right? So we can think about that. If we know some point on this plane figure, we know its velocity and we know its acceleration. So we can always divide this plane figure is plane motion into one translational motion is velocity or acceleration with the basic point A, our reference point A, our pole A. Another is rotation component, which is around pole A, right? So any other point, you can arbitrarily select letter to denote any other points on this plane figure, let's say M. So we can always use the same principle like this. So we can first write this pattern of a vector equation. Let's see, Vm means this point M is absolute velocity will equal VA. Why? Because A is the pole, is the reference point, plus VMA. That is our point M is the relative rotation around the point A, right? So I can change another color to show you guys. We always use the same method to have the similar result. So first we can link MA. Actually this M is I arbitrarily select. I want to find the absolute direction and magnitude of VM. So first I can draw like this VA. This is VA. That means is translational component along or with this pole point A. Another is its rotational component around A. So since we know it's omega around CCW direction, right? So we can use the same method. We can prolong this AM a little bit. So I just use the dashed line. Then we can rotate this dashed line along this direction of omega, that we can get this. So this will perpendicular to this whole line, OAM. So this is VMA, Then we can use these two vectors to constitute a what? A parallelogram. That's the principle of two vectors is sum. Then we have this point and we link that. You see, actually this Vm is what we want. That means this vector denotes the absolute velocity of point M. More like this, more like this. Because if we know the more information of the pole point A, then the task will be easy for us to find the results. Actually, we also have the similar composition of acceleration. So actually, we can write like this. AM equal AA plus AMA, So here is a little bit difficult because we will learn this before. Actually, if you are, imagine you are sitting on point A, right? You'll find the point is along the CCW, round, like say point B, have rotational movement along this a circular path or trajectory. Then from what we have learned, natural coordinate system, do you guys still remember? Actually, we can give this AB, this AB, let's change this AB, this ABT, right? This ABT can be divided into two components. The first one is ABAT along tangent line. Another is ABTN. ABTN. Why? So that we have learned because this point B will around A have a relative moment along the fixed trajectory. So we will have, it will AB will equal AA plus ABAT plus ABAN, right? And we will have that ABAT. It will equal alpha if this plane figure also have angular acceleration alpha, LAB. And ABAN will equal omega squared times LAB. So actually that's how the whole that's the whole chapter 9 will talk about the two composition method, right? So today we are just to talk about composition of velocity. Actually, we also have the same pattern composition of acceleration, right? So I hope you guys have impression here today, and maybe next time we'll talk about that in detail, right? So let's see. That's a conclusion. The velocity of any point in the figure which has a plane motion is obtained as the geometric sum of velocity of the pole A, right? Pole A, and the relative rotational velocity with respect to pole A. Right? That's how we have this expression. Such a method of finding the velocity is called method of pole. Actually, in Chinese, we call that 基点法. I'm sorry, I'll write it again. 基点法. So here, pole, well, I think it's more easily for you guys to understand the reference point. So that means we should select a point on this plane figure as the reference point. Then we can use the information of this reference point, including its velocity information and acceleration information. We can find any other point on the same plane figure, its velocity and its acceleration, plus maybe we can find the whole plane figure, its angular velocity omega and angular acceleration alpha, right? That's how we use this method. We call that method of pole. Actually, in Chinese, we call that 基点法, which is the basic method to find the velocity of a point in a figure. Actually, this is a plane figure. It has a complicated movement. That means it has a plane motion, right? That's our final conclusion. That's our ultimate method to tackle some problem, right? Maybe we will see some examples. Let's see this. I can just eliminate all I have right here, and we should analysis together again, right? So let me do this. So here you guys can just follow me and take a look at this. So this is a sample example on our textbook. So maybe you guys can back to that textbook to read it again after our class. I hope you guys can understand my explanation. So let's say in a crank slider mechanism, we call that this is crank slider mechanism. In Chinese, we call that crank slider. We call that 曲柄滑块 mechanism means 机构. So have you read for you guys? We call that 曲柄. What is 曲柄? It means it is a raised body. It can rotate around some point or axis with 360 degree. And so that we call a 曲柄. If it can only oscillate from with some fixed angle, we do not call that a crank, right? A slider means a box. It can moving along some trajectory like this. So we once again have a fixed slot, 固定槽. So it will guidance or constrain that this slider only can movement up and down through this vertical line, right? So we call that slider means 滑块 because it only can translational movement. And mechanism, we call that 机构. Actually, here 机构 actually is the body system. So if you guys know its principle of this crank slider mechanism, maybe it's very easy for you guys to analyze this. So we have OA, its length will be little r, right? And the length of AB is L. And crank OA rotates with the constant angular velocity omega, also CCW direction, right? As shown in this figure, find the velocity of slider B. Find the velocity of the slider B. Actually, from my analysis, you guys will know, we can give the conclusion that slider B is absolute velocity direction always downward or upward because the fixed slot have a guidance function to it, right? And the angular velocity of rod AB at this moment, when phi equal 45 degree. So first, let us analyze this mechanism together. So actually, if we give this rigid body with some number, we can give like this. So this is the number one. Actually, it is frame, frame. What is frame? Frame means earth ground, right? Actually, in China, we call that 机架. That means it will not move anymore. It always fixed on the ground. Then we can call that this OA with number 2, second. And this AB with number 3. And this letter with number 4. So first, we should analyze the movement of this 4 rigid body. So let's see. Number one, its frame is fixed, right? So at any time moment, its velocity and acceleration on this frame will always be what? 0, right? And let's see second. Second OA, actually it is the rigid body who had a simple movement, which is rotation around the point O with what? With the constant angular velocity omega. So that means if I draw here like this, so we have, this is OA, and it's along CCW direction with omega. So you guys should always think about that, what we have learned, what we have learned. That means, if we want, we can give any point on this rod OA is information of velocity and acceleration. Let's see this point A, so we know this direction will be VA, right? And we know that VA will equal omega times LOA, actually the omega R. See? That we have learned a rigid body have a rotation around fixed point O. And actually, if we have to get the information of point A, we also can give the, because it will have a tau along tau direction and AAN along N direction. And this guy, AAT, we have learned it should equal alpha times R. But we know it tells us crank OA rotates with the constant angular velocity omega because alpha equal omega dot. Because is angular velocity, so R equal 0. So this part have 0 value, and this part AAN will always equal what we have learned, that it will V squared over because he is flat, so it will equal what? Omega squared R squared over R. It always equal omega R. And its direction will along this direction. So this will be AA. No, that's the second rigid body on this body system. And what about this third? This third rigid body you can find actually at the point A. It has a constraint or connection with a rigid body OA. And here it has another connection with slider 4. Right? So this AB, we can say that it is a rigid body, do not connect the frame 4 directly. Can you guys hear me clearly? I will repeat. This link AB do not connect to the fixed frame directly, because at point A it is connected by OA, at point B it is connected by slider 4. So like this AB, it do not connect the frame directly. In many cases, it will have complicated motion, right? So that means AB, it will have the most complicated motion, that is, it will have a plane motion. Can you guys understand me? It will have plane motion.
Yes, Logic.
Okay, if you guys can understand that, it's very great. Then the 4, right? 4 is the slider, because the fixed slot is guidance. It only can movement along vertical trajectory, upward or downward. So this is another rigid body which have a simple movement, that is translational movement. Translational movement. So we know that actually translational movement is main characteristic is any two points on this slider B will always have the same velocity, same acceleration. See? And here it tells us and phi is 45. Maybe it has here is another hint, but do not show our problem. Actually, at this position, it's very coincidence. AB is perpendicular to OA, right? After all this process of analysis, we can try to find, you see, let us find the velocity of slider B and the angular velocity of a rod AB. So since after our analysis. You see, actually AB have complicated movement. That is plane motion, and we know a lot of information of point A because it is a point on AB. It's also a point on OA. So since we have VA and AA, O is VA's magnitude and direction, AA's magnitude and direction. So the better choice is we select point A as the pole on this AB. So if we try to find absolute velocity of point B, we can give as this: VB equal VA plus VBA, right? That's how we use this composition method because AB is a rigid body have plane motion, and A is a point on this AB and have a lot of information of its velocity and acceleration. So once again, you guys can find that VA actually should along AB direction. Why? Because VA should perpendicular to OA. We can just prolong OA a little bit, right? Got this. Then we should along the direction of omega rotate 19 degree. We will get VA, right? Since it's very coincident, AB also perpendicular to OB to OA, so this VA will just along AB direction. And we can find, since the guidance of this fixed slot, we know actually if OA rotate along this direction, actually there is a force from A to B. So the most I think we can find many of us can think because the push of this AB, this ladder will move upward. Maybe some guys difficult for me to understand that. I don't think AB should along upward direction. That's okay. If you cannot figure out that, you can just guess the direction of VB. So you can give a direction of VB. So if you do the correct calculation, you will find your results will have a minus sign. Actually, there the force from A to B. Then this ladder we pushed a movement upward. Then we give the direction of VB. And we just move this VA from here to here. So here is VA. And once again, we know VBA is the relative, actually it's more like we sitting on A. We look at point B, we find actually half rotation around A. But VBA, it should perpendicular to AB, maybe along this direction, also maybe along this direction. We must select one. The rule is we should make sure that VB in the diagonal position. Diagonal position. Do you guys understand this? That means 对角线位置 because VA and VBA is two vectors is always constitute a parallelogram, right? 平行四边形. And since VB equal VA plus VBA is always should at a diagonal position, right? VBA have no choice. It must perpendicular to AB first and along this direction second. Because otherwise, if you draw VBA like this, you cannot constitute a parallelogram, and then VB also at the diagonal position. You can find it's not correct because the guidance, the VB must along this vertical direction. So that's why. So if we know VBA should on this direction, that means, please follow me. That means omega AB will along this CW direction. You see? Why? So you can use the method I have described many times. So once again, this time we can prolong A, B, and B along the line, right? So we should rotate this 80 line with 19 degree along the direction of omega AB. Then we can get VBA. Since VBA already here, so we know we have to rotate this 80 line around the B with the CW direction. Then omega AB must with the CW direction, right? That's how we find the direction of omega AB. And we also know actually VBA is magnitude will equal omega AB times L. L is length of AB, right? So since, since we know this phi is 45 degree and here also is 45 degree. Can you guys find this? So because this angle, this line perpendicular to this horizontal line, and this line perpendicular to this line. So this two angle and this angle, it's two slides perpendicular to this angle's two slides respectively. Then if it hit 45 degree, it also is 45 degree. So you can find it very easy to find. We have we have a closed vector triangle. So this is VA, this is VBA, and this is VB. Our main task is what? Is to find the velocity of slider B and the angular velocity of rod AB, that is omega AB. So you guys look at this. We can find actually VA here will equal VB times cosine 45. Since we know VA here, so we know that VB will equal VA over cosine 45 is this. Then it was VA is omega times R. Over this, then it should be time square root 2 over 2. And then we will have VB will equal square root 2 omega R, right? We also can find actually, here we also have VB, VB times sine 45 from this triangle, because this triangle actually it is a rectangle triangle. So it will be VBA. And VBA should equal omega AB times L. Then we can easily find omega AB will equal what? Equal VB times sine 45. Right? And over L. So we have VB is square root omega R, we just have its magnitude, times sine 45 is square root 2 over 2, right? And this is L. Then we can find, because this guy and this guy will eliminate this 2. So that is the final result, omega R over L. That is our omega AB, that is our VB. So this is a typical example. Can you guys totally understand all these things? Can you guys understand what I have told you from this example? If you cannot, okay. If you can totally understand, that's great. If there's some problem still confusing for you guys, so maybe you can back to the textbook to read the book again. Maybe you can relook this record video, because some guy of yours are recording this class, right? And you guys can also ask me directly, right? I think that's all for this example. We'll move to another one, maybe. So let's see. this is a very typical example. Again, it tells the wheel, we have a very big wheel. Maybe it is a wheel from a car, right? It's poor rolling. So please, you guys, pay attention to here. We trying to call that pure rolling means 纯滚动 ，pure 纯滚动 ，rolling means 滚动。So what means 纯滚动? That means when this wheel is rolling from one position to another position, that means a different position it has different point which is contact to the ground, right? Since it is 纯滚动, that means in this contact point, there will have no relative movement between the point on the wheel and the point on the ground. That means, although it can roll from one position to another position, its contact point to the ground, let's say that point always be C, it always have the conclusion that VC equals 0. Right? Because it has no relative movement. Because that this kind of rolling is the pure rolling, right? So maybe it is the ideal assumption, but it can simplify our analysis of this. So let's see that this wheel is 纯滚动 with speed V0 along horizontal line, this V0. And the radius of the wheel is R, this radius of the wheel. So determine the velocity of point A, B, C, and D. So the first is, it's obvious that this wheel is a plane motion, right? It's a plane motion, P-L-A-N-E, motion. Why? Because we can think about that at different time moments. It will have translation parts and rotation part, because actually this wheel is rolling on the ground, right? It's a typical plane motion rigid body. So since we know actually this geometrical center O, it have what? It have a velocity of V0. Here it's not tell us this V0 is uniform. So this V0, that means we know, that means we should what? We should first select point O as the pole, as a reference point, right? So then we can write like this. So the first, maybe we try to analyze point A. So we have VA, equal V0. This is the pole point, right? Plus VAO. Then first we should give this direction. This should be VO. Another is VAO. We know what VAO it should, So maybe I should slow my speed. So we try to figure out what direction of VAO. So we know VAO should perpendicular to the link line between O and A, but it can be this direction. It also can be of the link line between O and C. So it can be this direction. It also can be this direction, but we know it should be this direction. Why? Because here should be 0. Because VC is absolute velocity because this point C, because this pure rolling condition, VC equals 0. So these two vectors must in opposite direction, right? Because VO not 0, it have be these two gases have to be opposites one to each other. If that's the case, means so we know when we sitting on the point O, we find C have a rotation velocity along this direction, right? So that means omega will be this. See? So that means angular velocity of this wheel will be what? CW direction, because the direction of VCO. You know, because VCO should equal omega times length between O and C, that is R, right? Omega R should equal V0. So that means omega equal V0 over R, right? And we also find its direction should along CW direction. So that is very important. After we finish this analysis, we get this omega is magnitude V0. Here, this VO, and our VBO will perpendicular to the link line OB, and no, we once again we use this aided line direction along the CW direction of omega, rotate another 19 degree. We find actually our VBO, right? This is our VBO. It also equal omega times R, so it also equal with 0. So you can find actually we got a rectangle triangle, and this red line is VB, so actually the magnitude VB will equal V0 squared plus another V0 squared. It will equal squared 2 V0, right? In that case, can you get understand? So we follow the same pattern, you know, we follow the same pattern. There is only one point we do not analyze. So we give this equation again, VD equal VO because it is a pole point, right? And that is VDO. So first we'll draw V0 here. So this is VO, right? Another is what? Another is we know VDO also should perpendicular to this link line dO, and along the direction of omega. So once again, we can prolong OD into this, and we use this reference dashed line. Let this dashed line around the point D along direction of omega, rotate another 19 degrees. So we find this direction will be what? VDO. And its magnitude will be omega times R, also R, because OD also another R, also equal V0. So then this diagonal position will be what we want to find is absolute velocity of VD, right? So here we can move to here. We have another rectangle triangle. So you guys can find, once again, our magnitude of VD will equal 1 V0 squared plus another V0 squared, also equal square root 2 V0. So that's the whole process that we finish the analysis. Then I have some question or some finding. Let's do that together. So let's see. So you guys can find actually we have finished all the analysis of point A, B, C, and D. So let's see. We know omega equal what? V0 over R, right? So you guys can find actually VA in magnitude is 2 V0. So I will ask you guys a question. Can you guys tell me the distance from A to C? We can find actually AC it is the diameter of this circle, right? So that means the length of AC will be 2R, right?
Yeah, that's 2R.
Yes, that will be 2R. And let's use this 2R times omega, which is V0 over R. So it will be eliminated by this 2R, then we have the same result. That means VA actually equal omega times LAC. So that is a finding, right? So let's see another point B. We know VB is magnitude is square root second times V0. So we can try to use omega times the length LBC, right? LBC. So we can find actually here is R, here is R. Actually, LBC will be square root second R. So we have, omega equal V0 over R times square root 2 R. So you can find actually this R and this R are eliminated. We have the same result, square root V0. See? Another thing happened. Let's see VD. Also, we can find VD equal omega times LCD and then equal V0 over R times length LCD also is square root 2R. Also the same thing. And the final one, we see we can use omega times LCC, LCC, because the same point, this length will be 0, so it is 0. So can you guys find something? So although we use the composition method to find VA here, VB here, VD here, and VC here, but it's more like we have another relationship that all the point, maybe any other point on the wheel, let's see, VM, is always equal omega times LCD. MC, right? Because we have checked this relationship when the point M is A, the point M is B, the point M is C and D, it's always true, right? Right? This is a very interesting, finding, right? So it's more like at this moment, all the point on the wheel is rotating around the point C. So that's why all the points velocity equal omega times the distance between this point to this center C. So actually we call at this point, this moment, because VC equals 0, then this C is in Chinese, we call that 顺心. Maybe in English is instantaneous point center. That means in this time moment, there always has or exists a point on the plane figure. Its absolute velocity is 0, and all the other point on the plane figure will more like have a rotation around this point. We call that instantaneous point, right? I think that's all for today. Let me see, is there homework for you guys? Okay, we don't have homework today. I hope you guys come back to our textbook, reread what we have mentioned today. I hope you guys can truly and totally understand what we have learned today, right? I think that's all for today. 那么我们今天就上到这里吧，好吗？下课吧。
OK，老师，
好的，再见，再见。
再见，老师。
不客气，不客气，再见。